So if you're still having a hard time with tangent and cotangent, hopefully this will help you out a little bit here. So the first thing that you probably want to do is find the period, just like any other trig function. Remember that the pure period of tangent is pi, and then you want to divide by the coefficient of x, which is not, it doesn't really look like it, but x is divided by 2, so that means its coefficient is a half. And we're looking at pi. Then I want you to remember what you know about tangent, so like the normal parent graph. So y equals tangent of x, you might remember a couple of things. One of them is that it passes through, right, the origin, because the tangent of 0 is 0. You also might remember here that you had asymptotes at x is equal to negative pi over 2 and at x is equal to pi over 2. Well, now that the period is 2 pi, that's not going to work out all the same, but it still will be true, right, that if you were to plug in a 0, so if I've got y is equal to negative, oops, sorry, my pen froze there for a second. So if I've got y is equal to a negative tangent of x is 0, let's see, divided by 2, I'm going to get the opposite of the tangent of 0, which is 0. So I know it's going to pass through the origin. So that's good information. So when we go to graph this guy, and let's get some axes here. I'm going to make them just like dark black here. Oop. Yep, there we go. Okay, so I'm going to lay out my axes. Something like that. Okay, and then we're going to want to put some asymptotes in, but this time they're not going to be negative pi over 2 and positive pi over 2. Let's see. I'm just going to do my equal spacing here. So I went 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Looks like I'm right about here. Okay. So these guys, if my spans has got to be 2 pi, and I know I've got to cross through 0, so I've got to have pi on either side. So this is going to be a pi. This guy is going to be a negative pi. And the next time that I would get an asymptote would be at 3 pi. So let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It'd be this line right here. I did not do a good job of marking the one in between. Let's see, so this is pi. 1, 2, 3, 4, 5. Right here would be 2 pi. And then this asymptote would be 3 pi. So normally your tangent graph goes like this, right? Passes through the origin and then it increases. So this blue graph that I've got sketched in here, so you can tell why I always cheat and use the online graphing calculator here. So the light blue graph that I graphed here, that's going to be y is equal to the tangent of x over 2. But I wanted to have in here negative tangent of x over 2. So that's going to flip over the x-axis, and you really don't cross an asymptote like I just did. Okay, it's easier to do it with paper and pencil, I think, for these. All right, something like that. So your final answer is this bright green graph. So think about where it crosses through and think about your asymptotes. Now what if this was cotangent instead of tangent? So exact same thing, but cotangent. Well, the period is going to be the same, right? That's not going to change. The pure period is still going to be pi. The coefficient of x is a half, so I'm going to get a 2 pi out of that. If you think about what you know about the parent graph of cotangent of x, it doesn't pass through 0, 0. You get an asymptote on the axis there. X equals 0 is an asymptote, and so is x is equal to pi. So the point that it passes through is halfway in between, or pi over 2 comma 0. So what does that mean for us? Well, when we go to graph, let's see if I can get these grabbed pretty quickly here. All right, so my asymptote is not going to be until we get to, let's see, if my period is 2 pi, well, I better have an asymptote here on the y-axis, right? X equals 0 is still going to be an asymptote. And then, let's see, when I go 1, 2, 3, 4. I'll do 5 again just so it's the same scale as what I had before. I'm going to have to get a 0, and then 5 units later, I'm going to get another asymptote. So something like that right there. Let's see. So we could do another cycle if we wanted to. Right there, we cross. And then we would get another line. Something along these lines right here. Okay, so the cotangent graph normally, right, is positive in the first quadrant. So it starts up here. And this guy, you could also think of him as a decreasing function. And again, we're seeing evidence why I cheat and use Desmos all the time. Oops, totally missed that one. Really need to hit the root, and I did not mark my axes off, which is bad. I'll fix that for you. All right, there we go. So I said this had to be 2 pi, right? So 4 pi would be 2 cycles. So here's a pi, here's a 3 pi. So when I flip this guy around, right, because we've got a negative in front of there. So when we flip this guy around, he's going to look like he's increasing over all these little intervals instead of decreasing. Something like that. So this last guy here in the green is the y is equal to the opposite of the cotangent of x divided by 2. I forgot to label this particular curve, right? That guy is y is equal to the cotangent of x divided by 2, no negative in front there. Hopefully that'll help if you think about, again, where the asymptotes are and where it's crossing the x-axis. Kind of think about what it normally does, and then you have to try to adapt. So some things just aren't going to change. I didn't do it on this one, but if I were to plug in a 0 into, so I thought I grabbed a different color there. If I grabbed a 0 and plugged it in for this x right here, I'd be looking at cotangent of x, and the cotangent of 0, and the cotangent of 0 is undefined, right? So I've got to have a vertical asymptote there. Hopefully that'll help you think about graphing tangent and cotangent.